Welcome back. So in this video, we're going to talk about how do you simplify exponents, okay? So let's talk about exponents, for example. So let's say you have a number a, and the number is raised to a power m, okay? So the m is actually called the degree, okay? So the degree, okay? Or you can also call it the power, okay? And then a is usually the base, okay? So so in this video, we're going to talk about when you have different different bases with different degrees and you combine them together, what are the rules of combination, okay? So let's take an example to illustrate this. So let's say you have negative 5 raised to the power 6 times negative 5 raised to the power 5, okay? As you can see, the base is the same, the powers are different, okay? So the rule out here is, I'm going to put that in green out here on the right hand side. So the rule is if you have a raised to the power m times a raised to the power n, then that is equal to a raised to the power, because the bases are the same, you add the powers, okay? So it's a raised to the power m plus n, okay? So we're going to apply that logic out here. So then that's going to become negative 5 raised to the power 6 plus 5. All right. And that is equal to negative 5 raised to the power 11. Okay. Now, we're not done yet. A note about signs. Okay. So if you have a negative sign and it's raised to an even power, then the negative sign becomes positive. So the net expression becomes positive, okay? And then if you have a negative sign and it's raised to an odd power, then that remains negative, okay? So as you can see out here, in the case of the negative 5 raised to the 11th, we can rewrite that as negative sign raised to the 11th times 5 raised to the 11th. So basically we're separating the sign and the number, okay? And that's totally acceptable, okay? Let's just put a parentheses around the 5. Okay, so then the a negative is raised to the 11th power, which is odd. So therefore, the net is negative. And we'll just keep the 5 raised to the 11th and not worry about simplifying that further, because you can let your calculator do that, but you don't need to. You can just keep it as 5 raised to the 11th, okay? All right, pause the video. Again, pause the video if you need to work the problem yourself, which I highly recommend doing, and then unpause and check your steps, okay? Okay, let's take a look at another one. So let's say you have negative 4y raised to the 7th power. Okay, again, out here, notice carefully, the 7th power is actually, it applies to the negative sign, the 4, and the y, okay? So that means this is how I would do it. I would take the negative sign raised to the 7th times 4, raise that to the 7th times y, raise that to the 7th. Now, you don't have to put the parentheses, but I like to put parentheses because it just helps clarify things. What is raised to the power, okay? All right, so then we know that the negative sign is raised to an odd power. So therefore, that is going to be equal to negative. And then the 4 is raised to the 7th power, so we keep that as 4 raised to the 7th. And the y is raised to the 7th power, so we keep that as y raised to the 7th. And we're done. Let's try another one. Let's say you have 5 pt raised to the 4th. Now pay attention out here. The 4 does not apply to the 5. So that power does not apply to the 5, but this power applies to the p and the t. So that's simply 5 raised to the 5p raised to the 4th times t raised to the 4th. All right. Try another one. A little different. 3x squared y cubed, and the whole thing is raised to the 3rd power, okay? So now out here, that 3rd power actually applies to the y raised to the 3rd. It applies to the x raised to the 2nd, and it applies to the 3 as well, okay? So let's go ahead and split that up, okay? So we write 3 raised to the 3rd power, okay? Put a parentheses, x squared raised to the 3rd power, y cubed raised to the 3rd power, okay? Now here's where another rule will kick in, okay? If you have a raised to the power m and the whole thing is raised to the another power n, then that is equal to a raised to the power m times n, okay? So anything raised to its power raised to another power, then the powers get multiplied essentially. So we're going to apply that rule out here so that the first term becomes 3 raised to the third. The second term is x raised to the power 2 times 3, which is 6. And let me just go ahead and break that down. X raised to the power 2 times 3 and y raised to the power 3 times 3. And then if you break that down further, 3 raised to the third, that's a simple number. 3 times 3 is 9. 9 times 3 is 27. So that's 27. X raised to the power 2 times 3 is 6. And y raised to the power 3 times 3 is 9. There you go. Okay. Let's try another one. Let's say you have 6x square z raised to the fourth. The whole thing raised to the second power times x cube y z raised to the second power times and the whole thing raised to the fourth power. All right. So the way you want to do this is, again, the power out here applies to each and every one of those terms, okay? The power out here applies to this, this, and this. So, so we're going to go ahead and do this. So 6 square that, x square raised to the second, z fourth raised to the second, and then you have x cube raised to the fourth power, y raised to the fourth power, z square raised to the fourth power, okay? Let's go ahead and simplify it. 6 squares 36. X square raised to the second power is going to be x raised to the 2 times 2. So that's x raised to the fourth. That times z. 4 times 2 is 8. Z raised to the 8th. Then you have x cube raised to the fourth power, which is 3 times 4 is 12. Then you have y raised to the fourth power. And then you have z raised to the second and then to the fourth. So which is 2 times 4 is 8. Okay, at this point in time, you want to combine the x's and the z's, okay? So we're going to rewrite that as 36. And now when you combine these terms, x's, you're going to follow this rule out here, right on top. This rule. A raised to the m times a raised to the n is equal to a raised to the m plus n, okay? So out here, the powers basically get added. X raised to the fourth plus 12. That's for x. Keep the y as is. And z, again, same rule applies. 8 plus 8. So that net becomes 36 times x raised to the 16. Y raised to the fourth. Z raised to the 16. All right. Hope that made sense. Okay, let's try another one. This one is going to look a lot different. M square raised to the third power over m raised to the fourth raised to the second power. All right, so let's go ahead and simplify the numerator separately and then the denominator separately, okay? So the numerator becomes m raised to 2 times 3, and the denominator is m raised to 4 times 2. Which is equal to m raised to the 6th over m raised to the 8th. Okay, at this point in time, we can apply another rule out here. If you have a raised to the m divided by a raised to the n, then that is equal to a raised to the m minus n, okay? So if the bases are the same, then you can subtract the powers. The power on top, so the power that belongs to the numerator, you minus the power of the denominator from this power, okay? So applying that to this problem, you get m raised to the 6 minus 8, which is m raised to the negative 2. All right, hopefully that made sense. Last problem, okay? So let's say you have ab raised to the negative third over a raised to the fourth times b raised to the second. All right, so now the goal out here is to combine the powers, okay? And there's one lesson that we need to learn out here, okay? And I'm going to write it out here. If you have a raised to the negative m, then basically you can rewrite that as 1 over a raised to the m. Okay, so basically if you If you take the whole term and you put it under 1, then you get rid of the negative sign of the power, okay? Likewise, if you have something like this, if you have, let's say, a raised to the or let's say if you had this, if you had 1 over a raised to the negative n, well, guess what? If you take that entire term and put it in the numerator, then you get rid of the negative. So basically, if you switch sides, if you take a numerator, put it in the denominator, or if you do take a denominator, put it in the numerator, then the sign of the power changes, okay? So that becomes a raised to the n. Okay, so we're going to apply that logic out here. So let's go ahead and combine the b's. So let's take the b raised to the negative third and put it down here, okay? And then what we can do is we can push the a down as well, okay? So that way we get all the a's and b's on the same side. So that's going to be, now please please understand that even though a doesn't seem to be raised to a power, it really is, because that's a 1 out there, okay? So anytime a number does not have a power, that means it's a 1. So this becomes 1 over a raised to the 4th times a raised to the negative 1 times b raised to the 2nd times b raised to the positive 3. What happened out here? The a raised to the positive 1 went down and became a raised to the negative 1. The b raised to the negative 3 went down and became b raised to the positive 3. All right, so once we have that, now we basically combine the a's. So a raised to the 4 minus 1 times b raised to the 2 plus 3. That's 1 over a raised to the 3 times b raised to the 5th. And that's it. So hopefully all of this made sense. Please feel free to rewatch the video. Skip to the sections that you need most help with. And thanks for watching.